Good afternoon, students. Welcome to the summer course. And first of all, let me introduce myself. So students, I am Sunit Kumar and I am your mathematics teacher. So we started the chapter that is number systems on Thursday. So this is the second class for this chapter, number systems. So let us continue with where we stopped in the previous class, students. So students, we'll continue with the chapter, as I said, number systems. And what are the prerequisites for today's class? So what we covered in the previous class was number systems, where we covered what are natural numbers, what are whole numbers, what are integers, what are rational numbers, what are irrational numbers, and what are real numbers. So these are the things which we covered in the previous lecture that was on Thursday. And if you want to, if you have missed that class and you want to view that lecture, you can always go to our YouTube channel and we have shared the link with you. You can, see that video so that, the continuation of the class is there. Now, we also, learned about rational numbers. What are rational numbers? We also saw what are irrational numbers. And what are we going to do today in the class is we are going to, delve deeper into what are irrational numbers. And we are going to learn how to locate irrational numbers on the number line. Okay. So how do we geometrically locate irrational numbers on a number line where we generally, till now what we have learned is that on number line we can, plot rational numbers. Now, how to plot an irrational number on a number line is what we are going to do today. And then we are also going to, study about real numbers and their decimal expansions. So we will see last time also we touched upon this concept that decimal expansion of rational number is either terminating decimal or non-terminating and recurring decimal. We also saw that decimal expansion of irrational numbers are non-terminating and non-recurring or non-repeating. Okay. Is it clear, students? Are we all in sync? Okay. How many students took the diagnostic test on Friday? The personalized assessment test, the proficiency diagnostic test. Can you please raise your hand? How many students took it? Okay. So I think there are 4 hands which I can see. 5 hands. Okay. 4 hands. So there are 2 people who I think have not taken the test. Right? Kavin has also taken a test, I remember. Kavin, could you not take it? Yeah, Kavin, please ask what doubt you have for the 6 p.m. meeting. Okay, the purpose of the meeting on evening is to explain you your diagnostic test report. So we'll go through the report, what has been generated by the platform, and we'll explain you about the report. And then we can, have a personalized roadmap for you for next 1 month, how we are going to cover up the learning gaps which has come out in that report. Okay. So it will be a 10 minutes meeting with all the teachers. So one of the teachers will get associated with you and explain you your, report. Okay. Okay, student, let's start the lecture now. So locate root 2 on the number line. How many of you know how to locate root 2 on the number line? You can put your hands down. Okay. Okay. So let us learn how to locate root 2 on the number line. So what we do, we'll go step by step. So step by step, we'll see how to locate the root 2 on a number line. So first of all, what we do is draw a line, horizontal line basically for a number line. Let's say this is the number line which we have drawn. Okay. Now let's say this is the origin 0 and let's say this is 1 unit. And similarly, this is 2 units. Now the unit which you take can be 1 centimeter, 2 centimeter. It depends on you. Okay. So I have randomly taken that unit, but yeah, you can take it 1 centimeter, 2 centimeter or 4 centimeter, whatever you are convenient with. Okay. So now once you have taken 1 centimeter is too small a value. So it is always advisable to take a unit as 2 centimeters so that, it is easy to draw, do the construction which is required. Now, once you have drawn the number line, you have marked 0, 1 and 2 on the number line. What you will do is that either using compass or using the protractor, you can make use of anything. Draw a line perpendicular here. Okay. So once you have drawn a line perpendicular here, okay, now you will take this 1 unit here as well. You will cut that 1 unit here as well. So you have drawn a line perpendicular and you have cut 1 unit on this perpendicular line as well. So let's say this was O, this is point A and this is point B, for example. So this is 1 unit. This is also 1 unit. Now what you are going to do is join OB. So you will join OB by a straight line. Once you have joined OB by a straight line, now what you will do is you will take a compass, right? You will take a compass and draw a curve. Okay. So keeping the one end of the compass at O and the pencil at B, and then you will draw a curve. Okay. Once you have drawn that curve, so it will look something like this. So the curve will come and hit it here, for example. Okay. So I'll draw it properly. So this is the curve which hits it here. So let's say this point is C. So this point will be root 2. Why will that be root 2? Let us understand. Have you learned of Pythagoras theorem in class? You have learned of Pythagoras theorem in class 7th and 8th both, I suppose. Right? So OB is equal to this. This is hypotenuse because this is perpendicular. OA and AB are perpendicular. OB is the hypotenuse. Hypotenuse OB is equal to root under OA square plus of AB square. Right? So which is, we know that OA was 1 unit. So this is 1 square plus of 1 square, which will be equal to root 2. So OB, this length is equal to root 2. When I have kept my compass at O and drawn a curve like this, now this curve, we know every point on this curve is at a distance root 2 only. So this distance will also be equal to root 2 because it is the arc which we are drawing, and the arc will have same radius everywhere. So this point C is OC is also equal to root 2. This distance is also equal to root 2. Is this point clear to everyone? Has everyone understood this concept? Why OC is equal to root 2? Good, good. So now we know that OC is root 2. So on a number line, horizontal number line, we have been able to plot. So initially we were able to plot only these integers 1, 2. Now using this method, we can also plot an irrational number root 2 on the number line. Clear? Now, do you want to do it on your own? You can do it on your own in your copy as well. You have to have a compass. If you don't have a compass, quickly grab a compass from the geometry box if it is lying around, and have a pencil, right? A scale, a protractor. Draw a horizontal line. I'll repeat the step. So I'll write the step here as well. Step 1. So draw a horizontal number line. Step 2. Now the step 2 is plot 1 unit on number line, right? After that, step 3 is draw a perpendicular line on this point A. Okay. Step 4 is cut a length of 1 unit on this perpendicular line. So once you have cut it, right? Step 5 would be to join OB, and step 6 is make an arc with radius OB which cuts the number line at C. So OC is root 2 in this case. Is it clear, students? Are these steps clear, students? You will be able to draw this, you will be able to plot this root 2 on the number line on your own. Okay, great. Now let's come to the next one, students. Locate root 3 on the number line. Who is going to tell me how to locate root 3 on the number line? Can anyone tell me how to locate root 3 on the number line, students? You can unmute yourself and, discuss it in the class as well. It will make it more interactive. Anyone? How do we plot root 3 on a number line? Yes, Subhranshu, you are correct. Yes, Francis, you are also correct. Very good, very good. Good, good, good. So there are two ways of doing this, and I'm very happy that both the methods has been discussed in the chat. So it will be easier now. So let's take it one by one. Okay. So first we'll take the step what Subhranshu is writing, and then we'll come to Francis' step. I personally would advise one of those, which I'll do it once I have explained both of them. Okay, let's understand, students. So what we are going to do, first step is to draw a number line, horizontal number line, put 0 here, 1 here, and 2 here, right? Now at 1, what we are going to do, we are going to draw a perpendicular. To plot root 3, you need to have root 2 first. So we will draw a perpendicular line here, and we will cut 1 unit here as well. So this is 1 unit, this is also 1 unit. We'll join this. So let's say this was point A, this is point B, OB is equal to root 2. Now here, from here, the steps changes basically for root 3. There are two different methods, as I said. first method, we let us draw a perpendicular at B, OB, perpendicular to OB. So let's say this is a line which is perpendicular to OB. So this was perpendicular. Again, we have drawn a line perpendicular to OB. And what we'll do, we will cut 1 unit here as well. So this is 1 unit, right? This is 1 unit. So same length, we'll cut it here as well. Clear? So now let us join this. So this is, let's say, point C. So OC will be equal to √3. How? Let us understand it. First of all, what we saw was OB is equal to root under OA square plus AB square by Pythagoras theorem in triangle OAB. Clear? So here we have root under OA square is 1 square plus 1 square, which is equal to √2. We know OB is √2. This we have seen it in the previous question as well. Now we take triangle OBC. In triangle OBC, we'll have OC is equal to, now this again is a right angle triangle. OC is equal to root under OB square plus of BC square. Okay. OC is equal to root under OB square plus of BC square. Root under OB square means √2 square and BC square means 1 square. So this is 2 plus 1, which is equal to √3. So OC is equal to √3. Clear? Now, if I have to draw this, if I have to draw √3, or we have to plot √3 on a number line, what I'll do, I'll take a compass, I'll place it at O, take my arc as OC. So here what I'm going to do, I am going to place my compass here and take an arc OC, and then I am going to draw this arc. From O to C, I'll draw an arc which is going to cut this horizontal line at point D. Let us do it. So when we draw this arc, students, this is going to cut here, right? This is the arc. Now this is going to hit here D point, and this D point, because this is an arc with the same radius as OC. OD will also be equal to √3 only. So this point basically is √3. So this is how you plot √3 on a number line. Is this method clear to you? Is it clear to every student? Students, have you understood this concept? So this was what Subhranshu was suggesting. Okay. Shall I move to the next step? You want to, if you want to just draw it roughly, please do it. Or you can note it down and do it later. We can proceed with the next method. I'll give you, 30 seconds to quickly do it. You can roughly, do it on your copy, and then later on after the class, you can draw it and see it on your own. See, construction questions, you will be able to do it correct in exam only when you have done it in the class on your own or after the class on your own. Understanding is not a problem. The problem is to do it on your own when it comes in exam. Then you get confused at times that what you need to do first and what you need to do later on. Okay? Okay, Francis. Francis is writing something. Okay, now let's go to the next one, next method. Okay, I'll just rub this method. Shall I rub it, students? Give me a thumbs up if I need to, you have noted it down. Okay. So I'll quickly remove this. Okay. Now the other method. Okay. So what we are going to do here, first draw a number line. So let's say this is my number line, horizontal number line. Let us plot the origin O. Let us plot 1 unit here and this 1 and 2 on the number line. Let us draw a perpendicular here at 1. So here again we'll plot root 2 first, and then from that we are going to plot root 3. So we will take 1 unit on the perpendicular line as well. So let's say this is point A, this is point B. We'll join OB. So this is your 1 unit, this is your 1 unit. This will become root 2 units. I'll not prove it now. Okay. So Francis, I'll just go through the thing which you are writing. So your teacher has said that if I take the hypotenuse of the triangle and measure with a divider, trace it on a number line, I would get root 3. Is this correct? Yeah. So, hypotenuse of that root 3 wala thing, not root 2 thing. The distance root 3, the other hypotenuse. Yeah. The another right angle triangle which we drew, that was, I think, OB and C. So in that OBC, the hypotenuse, and then by divider, if you have measured it, and then you can trace it on the number line and you can get. So it's the same distance basically. So by compass also we are doing the same thing. By divider also you are doing the same thing. You are measuring that distance. So you are making it equal on the x-axis. So both of them is possible. Okay. So I'll explain that concept again when I'm doing it here. So first of all, as I said, we'll draw root 2. So we'll draw a curve here. So let's say this point is root 2. Now this point is, let's say, C. Now the other method which I was talking about, what we are going to do is again draw a perpendicular here at C. So we had one right angle triangle here. We'll draw another triangle with perpendicular here. And because this distance OC, this distance is root 2. Now what we are going to do, we are going to again plot 1 unit on the perpendicular point, this point, and then we join this. Let's say this point is D. Now in triangle ODC, right? This is the triangle I'm talking about, ODC. In this triangle ODC, OD is equal to root under OC square plus CD square, which is equal to root under OC is root 2 square plus 1 square, because CD we have taken as 1. So this is 2 plus 1, which is equal to root 3. So now we know that OD is root 3. We will draw the curve here, right? So this point E is going to be equal to root 3. Okay. So now coming to the question which Francis had asked, that can we use divider here? So if I'll tell you how to do that. If I have a divider and I have measured from O to D, right? Now this is same as OE. The length will be same. So I mark it OD here and then mark that, trace that at on the number line, horizontal number line, you will get that point OE. So either you draw this curve using compass and pencil, or you measure it by divider. It's one and the same thing. Or you do it by scale. There are various methods of doing it, right? So I'm telling you that method which has been prescribed in your NCERT. Clear? Did you understand this concept, how to, plot it? Yes, you can use any of these methods. You can use any of these methods, students. It is not necessary that you have to use, uh, that spiral kind of thing. The spiral kind of thing would be difficult for after root 3. Let's say you have to do root 5. So first you will have to make root 2, then root 3, then root 4, then root 5. So you will have to go 5 steps, right? But there are easier way of doing root 5. I'll tell you how. So any of these methods can be used, students. It's not necessary that one of the method is preferable or other is more preferable. It's only that the second method, this method which I have told you just now, this becomes easier for bigger irrational numbers. For example, root 5, root 11, root 13, root 17. So this method would be more easier. Okay. So let's go to the next one now. I hope everyone has noted it down and everyone has understood this concept as well. Okay. Now we'll quickly do some questions here. So first question, student, it is state whether the following statement are true or false. Justify your answer. First is every irrational number is a real number. Every irrational number is a real number. Is it true or false? Every irrational number, is it a real number? Irrational number. This is true, students. Why? Because we know that there are two parts of real number. One is rational, other is irrational. Both rational and irrational together forms real number. So every irrational number is a real number is true. As I said, students, see, in the number system which we studied in the previous class, what we saw was that natural numbers are the smallest, such system. So all counting numbers are natural numbers. Natural numbers plus 0 makes its whole number, right? And now then integer we have positive whole number, negative whole number, and 0 all together makes integers, right? So this hierarchy is going up. All natural number will be whole numbers, all whole numbers will be integers, all integers will be rational numbers, all rational and irrational will be real numbers. Is it clear? So rational and irrational together forms real number. The question is, state whether the following statement are true or false. Every irrational number is a real number. So because irrational number is a subset of real number, every irrational number will be a real number. It is true. Is this concept clear? Now, Hannah, is it clear to you? Has everyone understood this first question? Okay. Now tell me the answer of the second one. Every point on a number line is of the form root m, where m is a natural number. Can every point on a number line be represented as root m? See, we have root 1 equal to 1, then we have root 2, then we have root 3, then we have root 4 as 2. So every point on the number line is of the form root m, where m is a natural number. Correct. This is true. Okay. Third one, every real number is an irrational number. Opposite is not true. Every irrational number is a real number because, rational and irrational together forms real number. But every real number is not necessarily irrational number. It can be rational as well. So that's why this is false. The third one is false. Okay. So first was true, second was true, and third question is false. Clear, students? Shall we move ahead? Okay. Let's go to the next one now. Now, the question says, are the square roots of all positive integers irrational? So if you find a square root of all the positive integers, are all irrational? Not necessarily. If you take square root of 4, this is 2. This is not irrational. Square root of 9 is equal to 3. This is not irrational. So if not, give an example. So this answer to this is no. And if not, give an example of the square root of a number that is rational number. So square root of uh, 4 is equal to 2 and square root of 9 equal to 3. These are the two examples where square root of a number is a rational number. Clear? Is it clear, students? Shall I move ahead? Okay. Now the question is, show that root 5 can be represented on a number. How root 5 can be represented on a number line? Who is going to tell me quickly? Who is going to tell me how to plot root 5 on a number line? Yes, Francis, correct. 4 and 1. So whenever you have these questions, you first break it into two parts. Root 5 means 4 plus 1. So, if you write root 5 as root under 4 plus 1, this means root under 2 square plus 1. So that means on a number line, we will take 0, 1 and 2. And then at 2, we will draw a perpendicular and we will cut 1 here, 1 unit here. Now join this. Okay. Now this is point O, this is point A, this is point B. So OA is equal to 2 units and this is 1 unit. Clear? Not 4 base. You will have to take 2 as base because 2 square is 4 and then 1 square is 1. 4 plus 1, 5. Okay. So this is your 1 unit. Now what we'll do is taking OB as my radius, we'll draw an arc. And let's say this arc meets at this point C. This point is root 5. Now, how do you calculate that? Is by Pythagoras theorem, OB is equal to root under OA square plus of AB square, which is root under 2 square plus 1 square, which is 4 plus 1, that is root 5. So your OC is equal to OB is equal to root 5. Is it clear, students? Root 5, how to plot root 5 on a number line? Is it clear to everyone? Now, students, what I'll do, I'll quickly take you to the, our platform where you need to practice the questions on this chapter number system, the topics which we have already done. Okay, so I'll quickly take you to that slide. Can you see the screen and the platform here? Is it visible to everyone? Okay. So now what we are going to do, students, what you are going to do after the class, you have to log in on your platform with the login ID and password which you used for the proficiency diagnostic test. Go on the assessment section, click on the assessment section, go on practice, click on custom practice. And then when you scroll down, you will come to this chapter number system at the last. You have to do view topic, click on view topic, you will see all these topics. Okay. So now in this, what you need to do is you have to do this topic, assess number types to classify given numbers. Please note down the topic. The topic's name is assess number type to classify given numbers. This is the topic name. Is it clear? Can you see this topic? Under number system, you have to select this topic, assess number types to classify given numbers. And you have to practice questions on these today. So what you are going to do is, you have to open the platform, go on this topic, take a custom practice session for this topic. You will select this topic and then click on practice for selected topic. You can see the practice for selected topic on the left side. When you click it, you will have this practice session of 30 minutes. So you have to go on the platform, practice for 30 minutes. So today's homework is to do 20 questions on that topic. That is, you remember the topic, right? The name of the topic was, I'll again show it to you. The name of the topic is assess number types to classify given numbers. Okay. Will everyone practice today at home? Once you practice, students, you will get to know that what concepts you have understood and what concepts you have not been able to understand. With the use of platform, the analytics there will tell you that how much proficiency. You can see the proficiency. You will see that you have 85% proficiency on this topic. That means out of all the questions, you have been able to attempt 85% questions correctly, right? So you need to improve and you need to keep your proficiency above 95%. Is this clear? So that you will be able to understand that you have understood this topic completely. Okay, students? Okay, so please practice. Tomorrow I am going to ask you how many of you have practiced, and I can see those students also who are going to practice. So I have an access from backend where I can see whether you have practiced on that or not. So please complete your homework today, and tomorrow when we meet, we can discuss it, whether you have done it or not. Okay. So students, here I'll end the lecture. Thank you for joining in for today's class. Go back after the class is over. Go back and practice on platform for half an hour for each of the subjects which you have taken today. So I think you have taken one science and one maths class today. So do practice of half an hour for each of these topics so that you are confident on that topic, that you have understood the topic completely. Thank you, students. Thanks for joining in. Bye and take care. Have a very nice day.